Okay, this is part 3, and we are going to cover the control of this little fan. Which, these squares, incidentally, are 1/2 inch apart, and so this fan is 1.5 inches square. I think it's probably a 35 mil fan, and it's going to go on this heatsink that we talked about before in part 2. And to control its speed, we've got this little board I made, the variable speed controller. So it's for brushless or brushed motor, it doesn't matter. And the goals of this board were to make it as small as possible, because I knew in that power supply project there wouldn't be much room for it. And I've also got other projects that will need this, or I can use this in, and I wanted it to be compact as well for that. So I've got room out here in the corners with these dots. These are basically drill spots or drill targets, so if I want to mount this on 4 standoffs, I can do that. There's no circuitry under that area. Although it could even be trimmed off a little shorter if I was going to glue that in place, which I probably will do in the power supply project. So another goal was to actually, I started off making a variable speed controller that would just ramp up the speed when the temperature increased. Well, that was fine, except I decided that it'd also be nice to have a fan controller that didn't even run the fan when it was cool enough and turned on at a certain temperature and then ramped up. So I actually started with 2 circuits, and then this is actually the combination of the 2. So there's actually a different procedure. There's basically 2 modes, 2 procedures to set this up, and it can be set up to be stopped and then, turn on at a certain temperature and speed up when it gets warmer, or it can run at a minimum speed all the time if it's cold enough, and then speed up if it's warmer. So I've got a combination board here that I really like. And this basically took me a long time to make, and to get working and all that from scratch. But tell you what, it passes the winter in the north up here in Michigan, and that is a very good thing. So it's a lot of fun, and I don't mind at all how much time it takes. So I've got a little heat sink here, and that's got a voltage regulator that powers the output, so it's varying the output voltage depending on temperature. These white circles are potentiometers, so that's how the board is set up, either in mode 1 or mode 2, and that's very easy to do with a VOM. Here's a really cheap VOM that I picked up for just a few bucks, and actually it seems to work pretty well. Anyway, there's a integrated circuit right there, and that has a couple of operational amplifiers, and all these bits are resistors. Got some diodes in there, capacitor. I've got some pins here that are numbered on the board, this is V4 and V3. This is voltage 4, voltage 3. So the procedure just has me connect to the proper one, make the adjustment until it's what it needs to be, probably connect to a different one, make another adjustment. That's how it goes to configure it. I've got some holes here that are for the sensor. I don't have the sensor connected yet. Incoming power is not there yet. The motor's not there yet, because those are coming from the power supply board. And the sensor, of course, won't. And the sensor will just be, remote, maybe 6 inches away. And I'll put it somewhere in the case where it'll pick up a good temperature of the heatsink. And maybe I'll glue it right to the heatsink. What else is on here? Let's see, that's about it on the top. On the bottom, this is a single-sided board again. On the bottom, I was able to make, like I said in the other video, part 2, traces that are 1/100 of an inch wide. And actually, this, I can't get too close to the camera; it will not focus. But that one right there, I think, is 15 thousandths of an inch, and the one next to it that's really narrow is, I think it's 8 thousandths of an inch. So it's just under 1/100 of an inch. And that is just fantastic. I just can't wait to build a more compact circuit. Because if I can make these traces thin, I can move everything closer together. I can buy components that instead of, through hole mounting like these, I can actually buy surface mounted components, which are a lot smaller. But the board needs to be even better. It needs to be very, very narrow traces, very good quality to make that work. So I'm looking forward to that. I think that is all on the speed controller. So these guys are pretty awesome. I'm looking forward to actually seeing it run. So on to assembling this power supply, and let's see how it turns out.